This is Honors Geometry Lesson 9.1, Area of Squares, Rectangles, Parallelograms, and Triangles. So we know that a square and a rectangle are both parallelograms. So you can see they have the same formula. For a square, we can just say side squared because their base and their height are the same. But you can use the same generic formula, base times height. If you learned it length times width, it still works. Just be careful. Make sure when you're looking for the height, you look for the right angle. Don't use the side length of your parallelogram. That's not the height. The same is true for a triangle. Make sure you look for that right angle symbol so you know it's the height. And we know a triangle is really just half of a parallelogram or half of a rectangle. So the formula is going to be the same except we throw a 1/2 there. So again, just base times height, look for that height. Sometimes they draw it outside of there. It's a square, so it's side squared, or if you want to think of it as base times height. With the triangles, remember, it's half of a parallelogram, so don't forget your 1/2, base times height, 1/2. This one, they don't give you the base, so we're going to have to do some Pythagorean theorem to calculate it, and that's on the next slide we'll do together. And again, with an obtuse triangle, sometimes the height falls outside. So make sure you use that height. So it will be 1/2 base times height. I want to get to some of the more complicated ones. All right, let's start with some backwards ones. So they give us the area, they give us the base, and we're looking for the height. So take your time. I recommend you write the formula. Area equals 1/2 base times height. I know some of you can do this in your head, but it prevents mistakes if you take the time. So I have 36 equals 1/2. We're given that base is 12, and what we're looking for is the height. So I'm going to simplify. I'm going to take 1/2 of 12, gives me 6, divide each side by 6, and you can see that the height is 6. Okay. Same thing for a rectangle or a parallelogram. Write your formula, area equals base times height. Substitute the given information. In this case, our area is 276. Our base is the unknown. Height, again, they drew it outside. That's okay. Let's get rid of that 12. It's multiplication, so I'm going to divide. And let me get a calculator. 276 divided by 12. It looks like our height is going to be 23. All right, I want to get to some of the more complicated ones. All right, so we're going to find the area. This time they're going to have some missing information, and we're going to have to either use Pythagorean theorem or trig. So in this first one, I recognize it's a triangle, so I say area equals 1/2 base times height, and I can see that the base is this part, and it's part of it's missing, and we're also missing the height, so this one's going to take a little bit of work. I'm going to start with the Pythagorean theorem on this side to get the height. So I'll just call that x or whatever. So here's our 7 squared plus our x squared, or b squared if you want, equals 25 squared. So we get 49 plus x squared equals 625. 625. Subtract 49 from that. So I get x squared equals 576, square root both sides. It looks like our height is going to be 24. All right, so far so good. So I'm going to go ahead and put that in for my height. Now I need the rest of the base. So it looks like we're going to have to use Pythagorean theorem again. This time we're missing the part of the base, so I'm going to call that x again. It looks like they call it. So I'm going to say x squared plus our other leg, in this case is 24. We know, we just calculated that, equals 30 squared. So I'm going to take a shortcut. I'm going to say 30 squared minus 24 squared on my calculator, and I get x squared equals 324, square root both sides. And it looks like x is going to be 18. All right, so now I know the rest of the base is 18 centimeters. So I'm going to add that to my 17, and it looks like our base is now 25. Change color so you can see. Oops. All right, punch that in my calculator. And it looks like the area of our triangle is going to be 300. And remember, that's squared units, so it's going to be square centimeters. All right. This one, we're going to have to use a little trig. Let me just go ahead and make some room to work. Change color so you can see it. All right, so area is base times height, parallelogram, and it looks like they give us the base is 8. What we don't know is the height, but I know I can carry this 120 up here. I know consecutive angles of a parallelogram are supplementary, so I know this is 60. So I'm going to go ahead and drop my height. Oops, let's fix that. I'm going to drop this perpendicular. I'm going to carry this 6 over here. Okay. And so now we can either use our 30, 60, 90 triangles if you like that, or we can just use trig. I think I'm just going to use trig. So this is 60. I know it's sort of sloppy. Let me fix that. Okay. This is a 60. And I got that because consecutive angles in a parallelogram are supplementary. I carried my 6 over there. I know that because opposite sides of a parallelogram are congruent. Okay, so from the 60, I'm looking for opposite, and I have hypotenuse. If you go back to your SOHCAHTOA, opposite hypotenuse tells me I use sine. So I'm going to say sine of 60 equals opposite over hypotenuse. Cross multiply, I'm going to take sine of 60, and I'm going to multiply that times 6. And it looks like our height is about 5.2. I'm going to go ahead and put that in my formula. Multiply it times 8. And it looks like the area of this parallelogram is going to be 41.6 square units. All right. And this one again is Pythagorean Theorem. I wanted you to see this last one. It's an equilateral triangle, and we're trying to find the area. So it's a triangle, so I want to make sure I don't forget that 1/2 base times height. I know that my base is 8 units. That's given. We need the height. So what I'm going to do is I'm going to drop this perpendicular. It's going to split the base in half. That happens in an isosceles or an equilateral triangle. So at this point, I can use Pythagorean Theorem, but I also know that an equilateral triangle has all 60 degrees. And the 60 on the top in this case is going to be split into 2 30s. So you can use trig, you can use Pythagorean Theorem, or you can use our special right triangles. I'm going to use special right triangles this time because it looks pretty easy. I know across from the 30 is the short side, that's 4. Across from the 60 is the short leg times the square root of 3. So I know my height is going to be 4√3. So I'm going to go ahead and put that in my formula. And we're going to punch this in a calculator. So 1/2 times 8 times 4√3, and we get the area of this equilateral triangle with side lengths of 8 would turn out to be about 27.7 square centimeters. Okay, please try the practice problems. Let me know if you have any questions. Thank you.